Deep in the frozen darkness of the outer solar system, something is terribly wrong. 500 astronomical units from the Sun, far beyond Neptune's orbit, the paths of dozens of distant icy worlds appear warped and twisted by an invisible force. According to our best mathematical models, the most likely explanation is a hidden planet silently circling our Sun on a massive, elongated orbit. This mysterious world could be up to 10 times Earth's mass, and yet we cannot find it. Despite decades of searching, this hypothetical world remains stubbornly invisible, the most elusive object in our cosmic neighborhood. Astronomers have hunted for Planet 9 for over a century. Every survey, every telescope sweep has come up empty. Astronomers know something is out there. The gravitational evidence is overwhelming. Yet every attempt to photograph it has failed. In an era where we can photograph planets orbiting stars dozens of light years distant, the fact that something this massive could be lurking in our own solar system is genuinely disturbing. But everything is about to change. At the beginning of 2026, scientists discovered something extraordinary buried deep in data from a 40-year-old space telescope. Combined with information from a newer dataset, for the very first time, they may have an answer. Have scientists finally found Planet 9? Today, we're going to examine the evidence and determine whether this century-long hunt might finally be over. The outer reaches of our solar system remain deeply mysterious. Completely unlike the inner region we inhabit, it's so distant that even traveling at light speed, it would take more than 8 hours to arrive. 5.6 billion miles is an incomprehensible distance. To put that in perspective, light from the Sun takes over 5 hours to reach that distance. A spacecraft traveling at current speeds would require thousands of years. Upon arrival, you'd find darkness, peppered with unusual icy rocks we can barely detect. We call these trans-Neptunian objects, or TNOs. These frozen remnants from the solar system's formation hold crucial clues about our cosmic origins and potentially about the existence of Planet 9. Every new TNO discovered adds another piece to this cosmic puzzle. The first TNO was discovered by Clyde Tombaugh in 1930. You've definitely heard of it. It's called Pluto. However, it took another 60 years before we found the next TNO, and then an age of discovery began. Today, we've charted nearly 5,000 of these strange objects. But the most fascinating discoveries weren't the objects themselves. It was how they moved. Their orbits were telling us something extraordinary. Perhaps the most important discovery came in 2003, when a team led by Caltech's Professor Mike Brown decided to explore this outer realm. They quickly found Sedna, a dwarf planet less than half Pluto's size, but with an inclined, highly elliptical orbit that defied explanation. This sparked an explosion of interest in the outer solar system. Scientists rushed to explain why Sedna's orbit was so unusual. If it were just Sedna, it could be dismissed as chance. But increased attention revealed many more TNOs with equally strange orbits. Some crossed Neptune's orbital path. Others moved in the opposite, retrograde direction to all 8 planets. Many were dramatically inclined. The question became unavoidable. How did these orbits come to be? Random chance couldn't explain it. Something had to be responsible. Something massive lurking in the outer darkness. And the leading candidate was a hidden planet. The only hypothesis that explained all of them involves a 3-body interaction, known as the Leadov-Kozai mechanism. It states that a near-circular but inclined orbit can trade its inclination for eccentricity. But this requires 3 things: the Sun, the TNO, and a distant perturber. Mike Brown and colleague Dr. Konstantin Batygin modeled the orbits of 17 TNOs. They calculated the probability of their movements being random. The result was just 0.00006%. Instead, their model suggested these objects were being perturbed by an invisible mass, a planet-sized object hiding in the darkness. Enter Planet 9, a world potentially 5 to 10 times Earth's mass, orbiting the Sun at distances so extreme it takes 10,000 to 20,000 years to complete one orbit. If it exists, it would redefine our understanding of the solar system. The implications are staggering. a major planet we never knew existed, right in our own solar system. Now, we can model all we want, but the only thing that proves this is actual observation. Seeing is believing. You'd think since Planet 9 is supposedly in our solar system, it should be simple. Just point our telescopes at where it should be and take a picture. But this is exceptionally difficult. The brightness of a planet in optical light falls off at a rate inversely proportional to the fourth power of distance from the Sun, not the usual square of distance. Because for us to see it, the already diffuse light has to reflect back. Previous optical surveys from the Zwicky Transient Facility, the Dark Energy Survey, Pan-STARRS 1, all spent years hunting. None found a single candidate. Years of observations, millions of images analyzed, countless hours of telescope time, and absolutely nothing to show for it. The search seemed hopeless. Many began to doubt Planet 9 existed at all. Now, you might be thinking this search is hopeless, that Planet 9 is nothing more than a mathematical ghost. But hold on, because a team of scientists from Taiwan just changed everything. They found something hiding in plain sight, in data everyone else had overlooked. And what they discovered could finally end this century-long hunt. Stay with me, because what comes next could change everything we know about our solar system. There's something else we can search for. All planets emit their own radiation in the infrared spectrum. A new team led by Professor Tomo Goto and PhD student Terry Fan decided to exploit this. They searched two far-infrared all-sky surveys, the first taken by IRAS, the infrared astronomical satellite, in 1983. The second by Japan's Akari satellite in 2006. IRAS conducted the first ever all-sky infrared survey above Earth's warm, obscuring atmosphere. Its sensor was cooled to just 2.5 degrees above absolute zero using superfluid helium, negative 455.5 degrees Fahrenheit. It detected 350,000 new infrared sources ranging from distant galaxies to nearby asteroids. Akari had better spatial resolution and recorded longer infrared wavelengths. The combined dataset was truly massive. 2.4 million objects found across multiple decades. Filtering this enormous dataset for Planet 9 candidates seemed almost impossible, like searching for a specific grain of sand on an endless beach. But the team had a clever strategy. Instead of looking for visible light, they searched for heat. All planets radiate infrared energy, even in the coldest depths of space. Filtering this for Planet 9 candidates was a mammoth task. Fan and Goto had to track each object's position individually. Their strategy was to compare surveys across time, looking for objects that moved exactly as models predicted Planet 9 would. They searched for a planet between 7 and 17 times Earth's mass, with an orbital distance of around 26 billion miles at its closest, and as far out as 104 billion miles at its farthest. Objects closer than 500 astronomical units had already been searched by other groups. Terry focused on the area between 46 billion and 65 billion miles from the Sun. He predicted what angular distance Planet 9 should cover in 23 years. An object on a highly elliptical orbit moves much slower near its farthest point, so Planet 9 should spend more time in the survey area. This made the search slightly more favorable. The longer Planet 9 lingered in detectable regions, the better the chances of capturing it. Now came the painstaking work of comparing millions of data points. Any data that didn't fit the prediction was discounted. And incredibly, from over 2 million data points, Terry was left with only 13 candidates. From there, he painstakingly examined each one by eye, and was left with just one. In the top left corner of the IRAS image, there are 7 pixels warmer than the background. In the Akari image taken 23 years later, the candidate had moved 47.5 arc minutes, the equivalent of 1.5 full moons across the sky. If we saw these images in isolation, we'd never guess what they showed. But context is everything. We could genuinely be looking at the first image of Planet 9. Professor Goto says if confirmed, he may allow Terry to finish his PhD early, which seems fair enough. After all, finding a new planet would be one of the most significant astronomical discoveries in a century. The last time our solar system gained a planet was in 1846, when Neptune was discovered. If this candidate is confirmed, history could be about to repeat itself. We could be on the verge of the most significant solar system discovery since Neptune. Much of the data surrounding this candidate fits Planet 9 expectations, but there's concern from Brown and Batigan about the orbital inclination being too steep. The team hasn't completely mapped how it moves, but Terry doesn't think we'll wait long to find out. The telescope set to follow up is the Vera Rubin Observatory, featuring the largest camera sensor ever created at 3.2 gigapixels. It can capture objects orders of magnitude dimmer than previous surveys. Scientists believe it could increase known solar system objects by a factor of 100. As Mike Brown says, if you handed him money to build the perfect Planet 9 telescope, he would build the Vera Rubin Observatory. Its 10-year legacy survey of space and time generates 20 terabytes of data every single night.
Give it a few years, and we might know for certain. The technology is finally catching up to the challenge. What seemed impossible a decade ago is now within reach. The next few years could completely transform our understanding of the outer solar system. Meanwhile, Terry and Professor Goto have already found 2 other possible candidates. They're confident that if Planet 9 exists, they'll find it. But not everyone is convinced. What if measurements show it's not there? What then? Surprisingly, there are several alternative hypotheses. First is a new belt called the Zederic-Madigan, or ZM belt. Similar to the bar-like structures we see at galactic centers. Many small gravitational interactions rather than one massive perturber. Like a murmuration of birds, tiny interactions creating coherent movement without a conductor. If the combined mass exceeds 10 to 20 Earth masses, a single Planet 9 wouldn't be needed. This would mean no single massive body is responsible. Instead, thousands of smaller objects working together create the gravitational effects we observe. Second is a cosmic hit and run, another star passing through long ago. Its gravity tugging on outer bodies enough to cause the behavior we see today. Third is even stranger. What if our solar system captured a primordial black hole? These formed in the dense expansion phase of the Big Bang. One with planetary mass would be about the size of a football. Impossible to see unless it's consuming something. A truly bizarre possibility. A black hole hiding in our solar system? It sounds like science fiction, but the physics actually works. Finally, there's modified Newtonian gravity, or MOND, which claims to explain TNO orbits without needing Planet 9 at all. If MOND is correct, it would revolutionize physics. Our fundamental understanding of gravity would need rewriting. Either way, we're about to learn something profound. Whether it's a planet, a black hole, or entirely new physics, the answer will transform astronomy. Planet, star, black hole, or gravitational rewrite. What do you hope we'll find? Personally, I hope it's a planet. For those of us who learned about Pluto before it got downgraded, it would be nice to return to 9 planets once more. And who doesn't want to complete our understanding of the solar system? Regardless of what it is, the Vera Rubin Observatory is now searching. We're going to know for certain very soon. I can't wait to see what's actually out there. The hunt has never been closer to success. And you? Speaking of mysterious objects in the outer solar system, there's another world out there that's equally fascinating. Sedna, the distant dwarf planet that helped spark this entire Planet 9 hunt, is about to experience something extraordinary. A once-in-a-lifetime opportunity to reach it is approaching. And if we miss this window, we won't get another chance for over 11,000 years. Check out my video on the end screens.